So now we're going to start section 4.3, which is about increasing and decreasing functions and the first derivative test. So we're going to start at the beginning. We're going to talk about what it means to be, for a function to be increasing and what it means for a function to be decreasing. So we're going to start with the definitions. We're going to say that a function f is increasing on an interval I, or we'll just say on an interval, when for any two numbers x1 and x2 in the interval x1 less than x2 implies f of x1 is less than f of x2. So if you take a larger x value in your interval, it needs to produce a larger y value. And we're going to say a function f is decreasing on an interval when for any two numbers x1 and x2 in the interval x1 is less than x2 implies f of x1 is bigger than f of x2. So if I take a larger x value, it should produce a smaller y value if it's decreasing. So now that we know what it means to be increasing and decreasing, I want to know, how do I determine when a function is increasing or decreasing? Or in other words, how do I test for increasing, decreasing? Well, we use the derivative. So if f prime of x is greater than 0 for all x in the interval a to b, then we would say f is increasing on a to b. If f prime of x is less than 0 for all x in the interval a to b, then f is decreasing on a to b. And then the third option, if f prime of x equals 0 for all x in the interval a to b, then f is constant on a to b. So let's kind of relook at this. If the derivative is greater than 0, means if it's positive, your function is increasing. If f prime of x is less than 0, it's negative, means your function is decreasing. Now, if it's equal to 0, your function is constant. So now let's look at an example problem. So I want to find the open intervals on which f of x, which will be x cubed minus 3/2 x squared, is increasing or decreasing. So the first thing you're going to need to do if you're talking about increasing or decreasing, you need to find the derivative, f prime of x. So you would get 3x squared minus 3x. And now what you're going to do is you're going to set this equal to 0 and solve. So I can factor out a 3x out of both terms, and I'll be left with an x minus 1. So I'm getting two solutions here. From this first part, I'll get x equals 0. From the second part, I'll get x equals 1. So you're going to take those two numbers now and put them on a number line. Here's 0 and here's 1. And then what you've done is you've broken up the number line into 3 regions. I've broken it up into this piece, this piece, this piece, and this piece. And so what you need to do is you need to pick a test point, a number, in each one of those pieces. So let me go back here. Let's pick a number smaller than 0. So maybe -1. Pick a number between 0 and 1. Let's go with 1/2. Number bigger than 1. Let's go for the number 2. And we're going to plug these into our derivative. And we're going to use the factored form of our derivative. And see, is it positive or is it negative? So let's start by plugging in -1. 3 times -1. -1 minus 1. And really you don't need to know the exact number. You just need to figure out, is it positive or negative? So if I look here, that's going to give me a negative. And then here, this will be a negative. A negative times a negative would be positive. Now plug in 1/2. 3 times 1/2. 1/2 minus 1. So again, look for our sign here. This part is positive, and then this part is negative. Positive times a negative would be negative. F prime of, now plug in 2. 3 times 2, 2 minus 1. Look for our sign here. This first part will be positive. Second part will be positive. Positive times a positive is positive. So anywhere where there's a positive, my interval is, or my function is increasing. Anywhere there's a negative, my function is decreasing. So where is my function increasing? It's increasing anywhere that there's a plus. So I'll shade that part in blue. And it's decreasing where there's a negative. So we're going to write that in interval notation. So it's increasing on the intervals. So if I look at the blue part, negative infinity to 0, union 1 to infinity. And then it's decreasing on the interval 0 to 1. And there is my answer.